Hello all, hope you're all doing good. This is going to be an introduction to the OLC PixelGameEngine for C++. If you have any questions, feel free to unmute yourself, ask, or just write it in chat. So the PixelGameEngine. The PixelGameEngine is just a single header file you can include in your C++ program. And the reason that I really like it is because there's no big setup, there's nothing extra you have to install. It's just one single header file you have to include. You can use 2D, 3D graphics. It's powerful enough in that somebody's made an entire Minecraft clone using this. So it's good for super basic graphics work, or you could program a full-on 3D game like Minecraft. You can import sprites, there's keyboard input, and it is simple to use. It was made by JavidX9 on YouTube. He makes amazing programming, general technical videos on just about everything you can think of. He has an amazing pointer video, which I always recommend to people who want to learn more about pointers. The OLC stands for One Lone Coder, and that's right here, the one lone coder who started this. The PixelGameEngine is just a purely open source project. It's made by a handful of people, and they're continually trying to work on improving it and adding more functionality. The is implemented in C++, C, Rust, Lua, and Java. C++ is what it's designed for. If you're programming in one of these languages, your mileage may vary just because it's programmed in and just meant to be used with C++ with all the classes and objects and all that functionality. It runs on Windows, Linux, Mac OS, TSP, and Switch. These three, there is a version for them out there, but it's unofficial, so you may find a couple more bugs. It may not be the most updated one, but the Windows and Linux ones, those are the ones that it's specifically designed for and maintained for. How to get started. So to start, you should install Visual Studio, not Visual Studio Code, the full-on Visual Studio IDE from Microsoft. You can use another IDE if you want, but the engine was designed to work with Visual Studio. I've had no issues with it installing any background libraries or anything else, so I would highly recommend Visual Studio. Then once you get it installed, just make an empty project. Don't use set up a console project or any other weird type projects. Just use an empty one and then add this file, the OLC PixelGameEngine.h file. You can grab that directly from the One Lone Coder's GitHub. It's right here. You would just click there, click raw, and then just do Control S, and boom, it'll be ready, and you can download it onto your system and just put it in your file. Then take the boilerplate code, which I'll go over, and then you can just mess with it, add, remove anything you want, and just start working. The starter code. So I've set up a little project here with a couple of examples. This is the .h file. It is a massive, almost 5,000 line file. And if you have any experience with C++, I would highly recommend you skimming over this a bit, just because it's written in a way where if you've taken 201, or if you're in like 341, or just have a good handle on C++ programming, you can read this and actually understand it fairly well. Like, this is just a struct. This is, a static constant. This is a struct for the keys right here. It references to a lot of different things. And you'll notice that all the libraries he imports are normal libraries usually used in C++. He's not importing anything crazy. Then here is the example program. Comment. So starting out in the example program, first thing you want to do is import the .h file. Then, if you know a little bit about the advanced concepts of C++, what it's doing is actually inheriting the PixelGameEngine class to get all of its functionality. Then here is your app name. This can be a string of whatever you want, as long as it's like it describes your app. Now, on user create function, if you've ever programmed with Arduino or any other basic graphics or hardware library, not library, well, platform, there's always two functions. One of them is the onUserCreate function. This is only ran once. So any variables you want to declare, any objects you want to declare, any memory you want to allocate once, that will go in here. Then the onUserUpdate function, this runs as many times as your computer can handle it. It'll keep on going as fast as it can go. It brings in elapsed time parameter. What this is, it'll essentially just tell you how much time has passed since the last time the function ran, and you can use that to control the operation of your program. Because if I run this program on a computer that's like super powerful, best top of the line, you'll get a lot more performance, and this function will execute a lot faster and on just a basic low powered laptop. So keep that in mind. I'll go over that in a bit more detail later in the slideshow. Then what it's doing here is it's calling draw and using the screen width and screen height to go through the screen, draw a pixel. And here it's instantiating the class, calling the constructor, and clicking start. Now I'm going to run it, and what it's going to do is it's going to open up the window. It takes a bit because it's putting stuff together. There we go. So this is using essentially vanilla C++ to make this window of all these different colors. And the way because these colors are moving around so fast, the reason these colors are moving around so fast is because I have it on the user update function. So it's being called repeatedly, and each time it's being called, it generates a new random value for this parameter right here. This parameter represents the color, so R, G, B, the three values to make any 8-bit color you want. Now let's get back to the slideshow. So as I said before, onUserCreate only ran once as soon as the application loads, and onUserUpdate, that's just a float that tells you the time that's passed since the last time it was ran. Setup, that's the name of the window. I forgot to show you that, but see up here, that's when you edit that string, it goes up here. So if I wrote IEEE example IEEE example would go here from there. And the constructor or the construct, this constructs the second window that pops up besides the console. You can specify a width, height, pixel width, and pixel height. So if you do a 1x1 pixel, it'll it'll simulate a normal display. So if I put 720 by 1080 or 720 by whatever the other side of resolution is, and put 1 pixel there, it'll be a 720p program, versus if I have more than 1 pixel, I can make it look more pixel-like, more pixelated. The general something to keep in mind is that the 0 pixel is here at the top left corner, and then the largest pixel with the screen width, screen height, that's here. So if you want to go move something to the left side of the screen, you're going to have to increment screen width. And if you want to move something down the screen, you're going to have to increment screen height. That's just to keep in mind as you're making something on screen and moving it around. And this is the second example, the bouncing ball. The code for these examples can be found right here. There's a link at the end of the slideshow for all of the files. So if you're interested in looking at them, see how they work, or just grabbing them, you can go to this URL. And again, I'll have that at the end of the slideshow. So the example. This one is a little bit more advanced. It's a bouncing ball. The big change in this is instead of just directly inputting my code for clear and fill circle here, I have this if statement, and what that's doing is that's setting up a timer variable right here, and that's adding the amount of time that's passed since this function's been ran. So that way I can control how fast this part of the code is executing. It's hard to explain in words, but I'll explain it visually in a second. So those are just warnings for conversions. But here's just a simple bouncing ball. that changes color as soon as it hits the side of the screen. Now it's moving at around 60 frames per second, I believe, and it's executing at this many times. This is the FPS, is how many times that function is being ran, but this ball is moving a lot slower than that just because I have this if statement condition right here. This is just a normal variable. There's nothing special about it besides that. If I were to go down here and set this delay to 0, then you'd see this ball bouncing quite a bit faster just because the function's executing at full potential. See, it's not as constant. The frame rate's dropped and this ball is a little more jittery. So if I ran this on a high-powered machine, moving a lot faster, or if I was running a program with it, it wouldn't be as constant in its movement. But because I have this delay here, it's only executing a certain time every second. So that's how you can control movement. Worse if you have a game that's based on input, because if I input something, then something will move a lot faster than it should. Now this is just a basic cout statement here. This is still C++, so you have all the functionality of normal C++. I can still cout anything I want. This is still a function, and I can print this out. This is just printing out the location of the ball every second. So this is the game window, and this is the location of the ball. It's moving that each time the function executes. So you still have access to all your basic C functions. Then, besides that, in here, I'm just calling this fill circle, which makes a circle on the screen, and calling this, it takes a parameter of X location, Y location, a radius, and a pixel color. Pixel color is RGB, and I'm setting those values right here. The way it changes color is that this velocity function that I built. So you can still make your own functions easily. This is one giant class, so feel free to just put void velocity here and make whatever code you want. I've made it so that each time it hits the screen width minus the radius, it'll regenerate a random value for these variables right here. And that's how the color changing works. And this is how it knows to hit the edge. It's not actually detecting an edge. If I didn't have this if statements here, it would go infinitely forward into space. But the way the bouncing works is as soon as it hits the edge of the screen height minus the radius, it just reverses direction. Instead of adding this velocity would turn negative, and it would start adding a negative number to make it less. And I will go over this part a bit later. Besides that, these are just a bunch of basic variables to control direction, velocity, radius of the ball, and yeah, the rest of that's simple. This just goes a bit more in depth with the timing code. So this if statement just adds the time between frames. This is the timer, the delay you want. Then you can put whatever code you want in here. This code can be as complicated as you want, as long as you remember to decrement counter and have it inside of that if statement, you'll be perfectly fine. Clear function. So when you're writing this user update function, it's not actually clearing the screen, it's just drawing over on top of it. So what this does is that it makes the entire screen a giant black square. If I were to comment this entire function out, it wouldn't be clearing the past frames. So instead of it being a bouncing ball, it would just look like a array of that, because it's not clearing the past screen at all, and it's drawing it on top of one another. So that is movement, but it's not a bouncing. That's why you want to have this thing here that's clearing the screen for you, and this can be any color you want, so that it's simulating the movement instead of just drawing on top of each other. And as I said, it's still normal C++. This is just one giant H file whose functionality you're grabbing, so you can make your own functions, your own classes, your own anything you want. You can even import other libraries, like other mathematical libraries, and program the OLC PixelEngine with that, just to make something really cool. I'm going to step up the difficulty one more time, and I'm just commenting out these files because each one of them has a main function there, and Visual Studio does not like that. There we go. So this is very similar to the past function, except instead of it being a bouncing ball, because this hasn't changed much at all, it's essentially the same. I've replaced velocity with process input, and what process input does is it actually grabs keyboard input, pressed, held, and the screen height, and just controls the ball with up, down, left, right arrows. So if I were to run this, um, nothing's happening yet. But if I move my up arrow, boom, it's moving around the screen. And it can detect edges because I have that code in there that detects when it's close to the edge. I can hold these two buttons down at once and it'll go fully vertical. You can make a full game out of this if you want. It's super basic. And the way the drawing's working is instead of, I don't have a clear function here, I've got this commented out. So it's a drawing application versus if I had this uncommented again, it would just be a ball moving across the screen controlled by your keyboard. See? You can easily turn this into a Pac-Man game if you added a bunch more functionality. So the way that's working is it's using this bit of code right here, and this function getKey accepts a parameter of OLC key, and that's just a giant enum. So if I were to go back here and scroll all the way down here, you'll see it defines an enum of all the keyboard keys on a standard keyboard. So you can escape anything you can think of, and then when you just want to use it, you say getKey, write the key down, and be pressed, be held. There's a reason that I have be pressed or be held, because what press does is it registers the input for a single frame. So if I get a key and hold it down, it'll register the key for that single frame, and then it won't do anything afterwards. If I do release, it'll notice the release for one frame, it won't do anything afterwards. But with held, it'll be able to tell if I've pressed the key and then, so if I keep on pressing the up arrow, it'll keep on running that bit of code for every single frame that I've held the key down instead of just running for this. So when I'm moving the ball up, I don't have to repeatedly press the up button. I can just hold it down and it'll move the ball up. And this is also a good way to explain the timing issues, because if I were to turn this to 0 and try to do the same thing there, it was moving at a fairly constant pace, the ball previously. So, but if I were to take that timing off, and if I did that, see how it's moving extremely fast, and I can't really have much control on it because that thing is just executing as fast as it can. It's moving, I've set it to only move 1 pixel per frame. It's being executed this fast. It's going to try to move as fast as it possibly can. That's why I have this delay right here, so that it can only move by, that's like, I mess with it until it seems smooth enough by that much, a constant amount. And just like you can do keyboard input, there's also mouse input right here. Now, mouse isn't an enum. I haven't actually been able to look in the code and find out the mapping for each mouse button, but if you put a 0 in there, it will be the left button on the mouse. If you put a 1 in there, it'll be the center button. And if you put a 2 in there, it'll be the right button on the mouse. And it works just like a keyboard key, a switch, where if you have a dot press and dot held, and it'll just use these functions, get mouse X, get mouse Y, to change the location so it follows my mouse around. And then you can do the exact same thing as you were doing before, except instead of using the up and down keys, you can use your mouse to draw. This seems a little cooler. It's changing color because I've kept this random here. Instead of rejang the values only times it hits the edge, I've just kept this random in here so that it's randomizing the values each time it's being ran. And I just implemented a clear key in case you fill up the screen. So if I put this everywhere I want it, and then I press C, close the screen. That's just calling the clear function. OLC get key C pressed or held. That's just calls the clear function. It's very intuitive. You just have there's quite a bit of guessing and testing involved, but it is simpler than some of the other stuff I've used. Mouse X, mouse Y works exactly about the same as getting a normal switch. Now I have one more example, and this is the most advanced of them all. So this drawing app is cool and all, but it's still all inside of a single class. That's helpful if you want to do functional programming and have something basic. That's awesome. But if you want to get a little more advanced, where you want to use multiple classes, the PixelGameEngine has a special way for you to call the functionality in other classes. So here, I'm just inheriting the PixelGameEngine class, and then I can use these functions, do what I want directly in here. But if I make a second class, so here I've made a ball class that just makes a tiny ball, and in the constructor here, I've just put in a pointer to the PGE class. And then when I'm constructing it, what I do is I just do set values or call the constructor here and put this there. And that's this keyword just points to itself. It's just a pointer to the class you're currently running it in. And what that does is it brings in all of that functionality as a pointer. So if I wanted, instead of just grabbing screen width, I'd have to do PGE arrow screen width. Or if I wanted to get mouse input, I would do PGE get mouse. Now you'd be wondering why I want to do it that way, because it allows you to do object-oriented programming. So now if I go down here and this is the amount of balls I generate, if I just put one in there, it will generate a single ball that moves around. But y'all have seen that before. So if I want to make this more advanced and make it so that I can generate a lot of balls at the same time, I can put like 100 in there. And what it'll do is with almost the same amount of code, I can turn that ball into an object and have it generate all these balls at the same time. Ignore the edges, they sometimes get caught. But it'll have all these balls and they're all working independently of one another. So I can make this more advanced by having detect if it hit each other, but that would slow down your program quite a lot. But yeah, that's with just, instead of, I took the exact same code I had here, the same velocity function, and put that in a separate class and just create a constructor, created an overloaded constructor and another function to set the values. And I was just able to allocate an array of them, set that array so it uses the pointer, and then notice I'm putting this into the user create function because I only need to make that once. Then just going through for each one, putting B1, BI circle, BI velocity, and having it generate each ball separately, but also using one single array for it and not having to make 100 different ball objects and run this function on each of them. That'd be boring as hell. And that's about it. That's the basics to the middle of how to understand the PGE. And these slides are for later reference in case you want to go and build something. You can just make a constructor, put the pointer in there, and you'll be able to utilize all the functions, complicate more advanced programs. As I said previously, PixelGameEngine is meant for simple game making, but you can also use it to work with a database and display a bunch of data on screen or do some data analysis stuff. And like I think somebody's used this to make a Fourier analysis or a Fourier transform program that shows the different waves on screen. Imagination is quite literally the limit. And at the end, the resources. So the number one resource I would recommend to learn this engine is just to go to the wiki. That's on the GitHub for the page as well. That's got a bunch of tutorials on how the buttons work, how collisions, resource packs, sprites, user input. The red ones haven't been implemented yet. If you get advanced enough, you could easily write this yourself and put it in as a pull request. But this is a very good example, and it teaches you a lot about programming and how you can take what you've learned in classes like 202 and 341 and make something cool out of it. Another thing I would highly recommend is this is his channel, JavidX9. As I said, he makes amazing videos on most nerdy stuff. Like I think he has a robot claw that he programmed with C++. He's done some C++ and networking tutorials. This is his website, and the number one resource besides the wiki I would recommend is the Discord. He has a wide community, and they're very active on Discord. So if you get stuck somewhere or need help figuring like debugging a bug, you could just go in there, post a question, in about like 5 to 30 minutes, somebody will reply to you. It's just a bunch of random people working together to work with the engine. This is a link to our GitHub to grab all the slides and well, not the slides, but the code that I used today. These slides can be gotten from the IEEE general channel. There's a link to the entire folder of all the GPMs. But that's about it. Get out there and make something cool. Any questions?